Hi, this is Tim with Byrd Appliance. Today we're looking at a Roper dryer. This could also be a Whirlpool style dryer, Kenmore, Admiral, Amana, Estate, anything made by Whirlpool. And it needs to have this mechanical style knob on it. It's the one that makes noise when you're spinning it around. Anyway, what we're looking for is why a dryer is not heating. So what you've got is a situation where you hear the motor running, you see the barrel tumbling, but you're not getting any heat to your clothing. And what you're going to need for this repair is really just a multimeter. If you have one, it is important to have one. And then also a 1/4 inch nut driver. And most everything you're going to be looking at for the heat problem on this style is in the back. So we're going to go and spin it around. And then everything that you're going to need to get back here, you're really just going to need to take the 1/4 inch stuff off of the back. So you're going to have a back plate here. It's 1/4 inch bolts, screws, and then 1/4 inch here as well. And that should take care of it. You should have access here. Before we start with looking into this, we do want to check one thing, and that is the voltage to the machine. Sometimes you can just have a problem with voltage. We're going to show you how to do that right now. On electric dryers, you have two types of outlets. You have a 3-prong and a 4-prong. We're going to show you how to look at both. What you got is two live lines. These are them, 1, 2, and they put out 110 a piece, more or less. It doesn't have to be perfect. And then a neutral. So what we want to do here is to double check. You should be getting somewhere between 220 and maybe up to 250. That should run the dryer fine. Put those in here and search around for your 250. Here, each line will be 110 to 120 typically. And again, with the neutral and the live, it should be 110 to 120. You can also have this style. This is the newer style. It's a 4-prong. Works the same way. Basically, your two live wires are here on the sides. That should be 240. Here should be around 240, 220. This should end up around 110 to 120, 110 to 120, and there is a ground. So, you know, you could check here if you wanted to. There shouldn't be any voltage between your neutral and ground. And then 110 should follow through here as well. But anyway, what we're really looking for is to make sure that this has a 220 to 240 live voltage. So just be careful if you're not used to working with voltage. And now we're going to get back to the machine. At this point, you need to have the machine unplugged. Alright, we're looking at the back of the machine, and we want to find out what's going on with not heating. So you're looking at things on the heat circuit. Just to go through it, what we're going to start with is all the stuff here is on the heat circuit. You're looking for 0 ohms on these thermostats. This would be the high limit. Generally, you always want to remove 1 when you're doing an ohms test. Again, this is in ohms. We're looking for 0. Be helpful if I had it on ohms. Alright, so that one checks out, so we have no problem there. Next, go down to the operating thermostat, which is down here. We're going to check both ends of it. And that one checks out as well. We can do the same thing with the heating element. Rather than pull too hard on this one's kind of stuck. What you want to do is we're going to show you real quick how to pry this off the easiest way so you don't damage the terminal ending and you don't damage the wiring. Alright, and on some of these, the heat here makes these terminal endings stick pretty well. You don't want to be yanking at the wire. You want to make sure you put some pressure here to prevent the thing from cracking or breaking. It's easy to sometimes do this, to twist it to get it started. You just want to twist the flathead screwdriver back and forth. This one's having some trouble. We don't have enough leverage here, so we can try to pull it. You want to pull from the good part, usually right behind the piece. Even then, it's pretty stuck. There it goes. And then we're going to test for ohms. This is going to be a little higher because there's a heating element in there. It does have some resistance. And on this one, it's around 10 ohms. That's normal. Alright, so if that checks out at 10 ohms, you don't find any open circuits on these 3, then you're going to move on. Before we do move on, if you do find it open here, generally that's a problem with heat inside the machine. You're going to need to make sure your ductwork is cleaned out. Also, any duct behind here, make sure that's cleaned out. This is a high temperature thermostat. This also works with temperature as well. This is usually 40 to 50 degrees lower. It opens and closes as it reaches that temperature. This is just for protection. So if this one's blown, it's a good idea to replace both thermostats. This one may be acting weird and not opening on time. This is the safety. So we typically replace these in pairs if you find this open. Now another thermostat that's involved in the heat is over here. It's got 4 wires to it. And so on this one we want to pull this off, and we're going to look. And there again we find 0, so there's no problem with heat there. And then we're going to move to the timer. These are really the main 4 back here. They're going to cause this heating element not to get hot. Now we're going to look at the timer. And if you look on the back here, there's 2 screws. You need to loosen those up. You really can do this without loosening up, but we want to show you what's going on. And that'll allow this piece to slide away. It's on clips. Now we're looking at the timer. Alright, now we're looking at the timer. Now every timer is different, okay? But what typically on these, you're going to look for the big fat wires, and the 240 volts that runs through the heating element are commonly the black and the red. It's not always the case, but so we can't tell you this for certain with your model. But on this one it's the black and the red. What you want to do to test this is turn your timer to somewhere where it's heated. We'll just use the high heat here at 25 minutes. That will close the switch. It's going to allow voltage to pass through here. Again, we want black and the red, and this one is A and C. We're going to test for ohms. 0 ohms because this is just a switch inside the timer. And we're not getting any thing there, so that's actually the problem here, is the timer. If that was 0, there wouldn't be a problem with the timer. I'm going to try it on one more setting just to be sure. And yeah, this is what's causing the problem here. Again, that's open, so there's not allowing voltage to go through down to the heating element. Alright, so on these older dryers with a mechanical timer, going back through everything, you want to check for the high limit, you want to check here, here, the other cycling thermostat. I'm reading the wiring diagram so I don't miss anything. You've also got the timer. Again, you're going to look for the black and the red typically, pull it away, check for the closed circuit, then that'll eliminate the timer as the problem. And then ultimately there's one piece that's really difficult to test, and that's at the motor itself. There is a centripetal switch that when the motor is running, it will close, and that allows the voltage to get up there. It's a fail-safe to keep the machine from heating when there's no blower wheel turning. So if the motor is running, that switch is closed. It's very difficult to test while you're trying to look through it. So that's your final one. That would mean there's a problem with the motor and you need to replace the motor. But again, you know, that's not very common at all. This is really where you're going to find issues. So again, for a dryer not heating, if it's a Whirlpool, Roper, Amana, Estate, Admiral, all these older ones with the mechanical dials, this is the way to look for problems with not heating. Thanks again, this is Tim with Byrd Appliance.